At 2 in the morning, an astronomer in the Canary Islands pulls up a new frame from the 2-meter twin telescope and stops scrolling. There is a jet of gas and dust coming off a small, fast-moving object, and it is pointed the wrong way. It is firing straight at the sun. Within hours, the image is circulating with a headline that has nothing to do with what she actually found. Oumuamua is back. Forums light up. Old 2017 footage gets reposted next to the new picture. Someone claims NASA has confirmed the return of the object that once made half the world wonder if we had just been visited by a machine from another star. The claim spreads faster than anyone can check it, because it promises the one thing every space story from the last decade has been building toward: a second chance to look our first interstellar visitor in the eye. By morning, clip channels have stitched together the old 2017 illustrations of a cigar-shaped rock tumbling through the dark with the new jet photograph, and the caption writes itself: NASA confirms Oumuamua is back. But it looks completely different. The video gets millions of views before a single working astronomer has time to respond. This is how a real observation made by a real telescope on a real night turns into a claim. That has almost nothing to do with what was actually seen. To understand what is really happening above our heads right now, you have to go back and ask a more basic question first. Could Oumuamua even come back at all? Here is what NASA's own tracking data actually says. Oumuamua was discovered on October 19, 2017, by the Pan-STARRS survey in Hawaii, moving at roughly 87 kilometers per second, on a path that could only have come from outside the solar system. It swung past the Sun, sped up in a way ordinary gravity could not explain, and kept going. It crossed Mars's orbit, then Jupiter's, then Saturn's, and by the time astronomers lost it in early 2018, its course was locked. Hubble and Spitzer tracked it long enough to confirm it is heading toward the constellation Pegasus on a one-way trajectory that will carry it past the Kuiper Belt and out through the heliopause around the year 2038. It is not slowing down. It is not turning around. According to the researchers who study it, Oumuamua will never come back. Not in any of our lifetimes, not ever. Scientists have spent years trying to explain the one genuine mystery it left behind, that unexplained boost in speed as it left. And the leading explanation involves hidden pockets of frozen hydrogen breaking down inside it, quietly pushing it forward like a very slow rocket. Strange, yes, but explained by physics, not by intent, and certainly not by a return trip. So if the object photographed off a telescope in Tenerife wasn't Oumuamua, what was it? And why did the rumor take off so easily? The answer is that the rumor borrowed its shock value from something real. In July 2025, a survey telescope in Chile called Atlas caught a fast-moving point of light that astronomers quickly traced backward through older sky images and forward through new ones. Its speed and its hyperbolic path gave it away immediately. This was only the third object ever confirmed to have arrived from beyond our solar system, after Oumuamua in 2017 and a comet called Borisov in 2019. It was named 3I Atlas, and unlike Oumuamua, which vanished from view within months, this one gave scientists an entire year to watch it up close, with instruments Oumuamua never had the chance to meet. Think of it like the difference between glimpsing a car speed past your window at night and having the same car parked in your driveway for a year. Oumuamua was the blur, gone before anyone could get a proper telescope on it. 3I, or Atlas, is the driveway. Every space telescope capable of pointing at it did. Hubble, Webb, Spherex, even spacecraft that happened to be in the right part of the sky for entirely unrelated missions, including Europa Clipper on its way to Jupiter, the asteroid-hunting Psyche probe, and Lucy, which was busy chasing Jupiter's Trojan asteroids when it caught 4 separate observations of the comet from 240 million miles away. ESA's JUICE spacecraft, already en route to the Jovian moons, managed a glimpse too, and even the sun-watching missions SOHO and Parker Solar Probe caught the comet crossing their field of view. No object from beyond the solar system has ever been documented by this many instruments at once, and what all of them found did not calm the internet down. It gave it new material. The first surprise was how early it woke up. Comets usually stay frozen and inert until they get close enough to the sun for ice to start turning directly into gas. 3I Atlas was already venting water while still far out in the cold at a rate of roughly 40 kilograms every second, long before any ordinary comet would have switched on. Then came the chemistry. The James Webb Space Telescope detected methane in its coma, the first time that particular hypervolatile ice had ever been confirmed on a visitor from another star system. Spectrographs found a ratio of carbon dioxide to water sitting around 8 to 1, among the highest ever measured in any comet, solar system or not. A separate team studying its water found unusually high levels of deuterium, a heavier form of hydrogen, suggesting the ice inside 3I Atlas formed somewhere colder and more chemically alien than anything that ever condensed near our own sun. Then the object did something even stranger. Instead of the classic tail streaming away from the sun, telescopes caught 3I Atlas producing a sunward antitail, along with jets, that appeared to wobble as the nucleus rotated, once every roughly 16 hours. Researchers had seen wobbling jets in a handful of solar system comets before, but never in something that had spent millions or billions of years drifting between the stars before it ever felt sunlight again. Some scientists estimated, based on how its surface had been altered by cosmic radiation during that long interstellar crossing, that the object could be closer to 12 billion years old, older than most of the stars in the galaxy's disk, and quite possibly a wanderer from a star system that no longer exists. For comparison, 2I Borisov, the second interstellar object ever spotted back in 2019, behaved much closer to a familiar solar system comet, just from somewhere else. 3I Atlas refused to play by those same rules from the moment it woke up. Once Hubble was able to separate the glow of the surrounding coma from the solid body. Underneath, astronomers pinned the nucleus down at roughly 2.6 kilometers across, with real uncertainty of a few hundred meters either way. That made it significantly larger and more massive than Borisov, big enough that some researchers began wondering whether a comet this size arriving on such a precise trajectory was itself worth a second look, before the chemistry data started arriving and gave everyone something more concrete to argue about. That is roughly the halfway point of this story, and it is worth pausing to be precise about what has actually been established. 3I Atlas is real. It is confirmed. It is the third interstellar object ever detected, and its unusual chemistry has already reshaped what astronomers thought they knew about how comets from other star systems are built. None of that required speculation. What comes next did. The strangeness of 3I Atlas's behavior did what strangeness always does online. It invited a bigger question. Could this be more than a comet? Harvard astrophysicist Avi Loeb, who had already made headlines years earlier by suggesting Oumuamua might be artificial, turned his attention to 3I Atlas almost immediately, cataloging what he called a growing list of anomalies. He pointed to the object's retrograde path, tilted only a few degrees from the plane in which the planets orbit, which happened to carry it unusually close to Venus, Mars, and Jupiter in turn. He calculated that the odds of a randomly arriving interstellar object threading that particular needle were vanishingly small. He noted a small but real non-gravitational acceleration in its motion, the kind of push you would expect from outgassing, but larger than some models predicted, and floated the idea that it could, in principle, indicate something closer to an engine than a jet of vented ice. He even pointed out that the region of Sky 3I Atlas arrived from sits close to where astronomers detected the famous WOW radio signal back in 1977, a coincidence he found too tidy to ignore. Loeb keeps something he calls the Loeb scale, a rough 1 to 10 ranking of how likely he personally thinks an interstellar object is to be artificial. When 3I Atlas was first discovered, he put it at a 4, an unusually high starting score for any newly found object of this kind, driven mostly by that same improbable planetary flyby geometry. If the story stopped there, it would be easy to walk away thinking the case for something artificial was strong. It is not that simple, and the caveat section of this story matters as much as the reveal. Planetary scientists who work with this data every day, including researchers who have spent their careers tracking comets and asteroids for NASA's near-Earth object programs, have pushed back hard on Loeb's numbers. Princeton astrophysicist Josh Wynn pointed out that assigning a tiny probability to 3I Atlas's particular trajectory only works if you decide in advance that this exact path is the one worth being surprised by. Almost any specific trajectory looks improbable once you ask, what are the odds of exactly this? And that kind of reasoning can make ordinary coincidences look engineered. Other researchers have argued the non-gravitational acceleration measurement carries far more uncertainty than Loeb's calculations assume, given how difficult it is to pin down the exact position of a fuzzy, glowing coma night after night. And in December 2025, when 3I Atlas made its closest pass to Earth, the Breakthrough Listen Project pointed the Green Bank telescope at it across a wide swath of radio frequencies. Their conclusion was blunt, no evidence of any artificial signal, and behavior consistent with what you would expect from an unusually active, unusually ancient, but entirely natural comet. A separate review of the same data, cross-checked with planetary scientists who study near-Earth objects for a living, went further, arguing that the specific non-gravitational acceleration Loeb relies on is likely much smaller than his published estimate once the measurement uncertainty is handled properly, and that even the larger figure would only imply the comet had lost a modest fraction of its total mass through ordinary outgassing, nothing that requires an engine to explain. Researchers also point out a more mundane reason 3I Atlas looks so unusual. It is only the third interstellar object ever studied this closely. It likely spent a very different amount of time drifting through the radiation of deep space than typical solar system comets do, and its surface chemistry shows clear signs of having been altered by billions of years of cosmic ray bombardment, an environment nothing in our own solar system experiences for anywhere near that long. Unusual does not have to mean engineered when the object in question is, by definition, unlike anything ever measured before. Even Loeb has adjusted his own position over time, lowering his personal confidence rating for 3I Atlas being artificial from that opening 4 down closer to 3 on his own scale, as more mainstream data came in, while still arguing the anomalies deserve continued study rather than dismissal. That is roughly where the object sits today. A natural comet, almost certainly, but one strange enough that serious scientists disagree about exactly how strange, and unusual enough that the disagreement itself became part of the story. As for where 3I Atlas is now, the answer closes the loop on the rumor that started all of this. The comet made its closest approach to Jupiter in March 2026, using the giant planet's gravity the way a slingshot uses tension, and it has been fading ever since, exactly as predicted, on a symmetric path back out of the solar system. It is not circling back. It is not settling into orbit. Like Oumuamua before it, 3I Atlas came from between the stars, spent a little over a year in our neighborhood, and is now leaving for good, carrying its unanswered questions with it into interstellar space where no telescope on Earth will ever be able to follow. So the headline was wrong on every count. Oumuamua did not return. It cannot, and its outbound path has been locked in since 2018. But something did arrive that looked for a moment close enough to reignite the same excitement and the same unease. An object older than most stars, chemically unlike anything born in our own solar system, active, in ways no comet should be this far from the sun, and trailed by a very public argument between one of Harvard's most famous scientists and the rest of the astronomical community about just how far strange is allowed to go before it becomes something else. Agencies including NASA and ESA are already designing missions like Comet Interceptor, specifically so that the next interstellar visitor, whenever it arrives, will not get the same head start Oumuamua and 3I Atlas both did. The plan is to keep a spacecraft parked and waiting in space, fully built and fueled, so that the moment a survey telescope spots the next messenger from another star, humanity can launch within days instead of watching helplessly as another rare visitor disappears back into the dark before we ever get close enough to really look at it. Here's a question worth sitting with before the next viral headline shows up in your feed. If a truly artificial object ever did cross into our solar system, would the evidence look dramatic and obvious the way the movies promise, or would it look exactly like this? A string of small, disputed anomalies buried inside thousands of ordinary, well-explained data points, easy to miss unless someone is looking hard enough to notice the pattern. Which of 3I Atlas's anomalies would have convinced you first? The sunward jets, the ancient ice, or the trajectory that threaded 3 planets in a row? Leave your answer below, because the next interstellar object is already out there, and it is only a matter of time before another telescope, somewhere, catches the first frame of its arrival.